Science Spectrum with Dawn. Thank you for tuning in. This is the 5th part of the 3rd lecture in measurement of physical quantities. Alright, now I would make some derivations of errors in products, just like we did earlier on, and I could extend that to errors in quotient and errors in power. Then we'll talk about measurements of length, mass, and time, and specifically would be detailed on how we use the instrument for measuring length, mass, and time. All right, so let's proceed from here. We stopped it from the previous class. So this is x into 1, or I didn't stick in the minus, plus or minus delta x over x. This is a times b, so I have a times b, and of course the product of this, that is 1 plus or minus this term. Now this term, we call this the fractional error. This is the absolute error divided by the measured value. This is called the fractional error or relative error times 1 plus or minus the relative error in the second quantity. Alright, now this will translate to the term on the left, x into 1 plus or minus the fractional error in quantity x. And of course, a times b, we saw that to be x. This is x, and I have, now I will open the bracket. So I have, 1. So I have x. Then this is, into bracket, 1 times the second bracket, that is, alright, so let me stick in, alright, is 1 into bracket 1 plus or minus delta b over b. Then the next term is plus or minus delta a, and it will multiply the second bracket, which is 1 plus or minus delta b over a b. Alright, now we could stick in a square bracket here. Alright, so you could see definitely if you open up the bracket, this I have x into bracket 1 plus or minus delta x over x. Then this is equals to x into bracket 1 times 1 is 1 plus or minus delta b over b. And I have delta b over b. I have the plus or minus delta a, right? Delta a times 1 is delta a. Then I have the plus or delta a, right? Times 1 is delta a. Then I have let's see, the delta a, this is meant to be delta a over a, so I have delta a over a, then I have plus or minus the product of these two terms, that is delta a over a times delta b over b. Now look at this, delta a over a or delta b over b, delta a over a or delta b over b. These terms, they are so small that we can even ignore, let alone when we multiply the fractional errors in both quantities. So this product of these two terms, we can really ignore. This can be ignored because it's very small. Alright, so if this could be ignored, I could just delete this part. And once I delete this part, what we are left with now is the next part will be, of course, I could delete the x here. So I have 1 plus or minus the fractional error in quantity x. And that is equal to 1 plus or minus the fractional error in quantity b plus or minus the fractional error in quantity a. And of course, I could keep the plus or minus the fractional error in quantity x, and I will transpose the 1 here. And the moment I do that, we figure out that I lose the 1. So what I'm left with now is the plus or minus in the fractional error in quantity b, then plus or minus in the fractional error in quantity a. And of course, I'm just interested in the positive parts. So what this will boil down to be, finally, would be plus or minus in the fractional error in quantity x. That is equals to plus or minus in the fractional error in quantity b plus the fractional error in quantity a. Alright, and of course, this same principle applies to quotients, so I may not need to bug you with this tedious derivation for the quotient. Just know that the product of the fractional errors in both quantities is always ignore because it's very small. So now you need to beam this a little, or I could proceed from here. So for reference purpose, so I could proceed from here. All right, then for quotients, we have for quotient, the quotient is when you have, you are dividing two measured quantities, right? And of course, you take into account their errors. All right, now for quotient, it's just a straight one. It's just like that, plus or minus in the fractional error in quantity x, and this would be just plus or minus the fractional error in quantity b plus. Okay, I will take the plus part, the fractional error in quantity a. All right, now, but you have to note something, that for the products, x is a times b, the product of the measured values. But x, when you have quotients, according to the question, you are dividing, it will be a over b. And of course, we could have for power, this is for quotient, Then for power now, errors in power. All right, just a quick one from here, and we'll just solve a few examples, and we go to measurement of lengths, the instruments, talk about the accuracy, and of course how we actually use that. So x in this case now is a raised to power n divided by b raised to power m. And of course, so this is now power, right? So this is equal to a raised to power n times b, this will carry a negative power n. And of course, I will take the log of both sides. So this will be the natural log, so to speak, of quantity x. This will be equals to, I could bring down the power, this is n times the natural log of quantity a, then plus, just bring down the power, that is minus m times the natural log of quantity b. Alright, now I could massage that further, and once I do that, straight to the point, I'll get the fractional error in quantity x, right? Then I could just stick in a plus or a minus. So I could just stick in a plus or a minus. So I could stick in a plus or a minus for the fractional error in quantity x, and this will be equals to n times the fractional error, that is what link A stands for, the fractional error in quantity A. Plus times minus gives me a minus, but I could also stick in a plus, right? Plus or a minus, then this is m, the fractional link B is the fractional error in quantity b. And like I said earlier on, I'm just interested in the positive value between the fractional error. The n and the m stands for the power to which the quantity a and b is being raised to. Alright, so this would finally boil down to be the fractional error in quantity x, and that is the power of quantity a times its fractional error, and I will pick the positive parts. Of course, I could, then the positive parts times the power of quantity b times the fractional error in quantity b. And of course, I could stick in a plus or a minus here. So this is for the products, rather for when you have the quotient of two quantities, and of course they are raised to a power. Alright, so we'll do a few working examples. We'll do a few working examples. You need to beam this for a while before I clean it up. So we'll do a few working examples. Alright, so the first example I'm particular about would be for, since we've done for sum of errors, difference of errors, then we'll talk about product of errors. So let's take, for instance, let's say I measured a rectangular object, and let's say its length was given as, it was measured, and let's say this is 10.2, and of course with a sanity of, let's say 0.1, of course let's say in centimeter, and let's say the breadth is let's say 9.4 plus or minus, let's say 0.2, of course let's say centimeter. Now the question is this, calculate the area, right, and error limits, and the error limits, and the error limits, and the error limits in the area, So straight to the point, what we simply do is this. We know the formula for the area of a rectangle. So the formula for the area of a rectangle is area of a rectangle solution. Area of a rectangle is the length multiplied by the breadth. Alright, and the length, I could multiply that, that's 10.2. And of course the breadth, that's 9.4. And of course, this is in centimeters, so this would give me centimeters squared. So of course I know the area of that rectangular object that was whose length and whose breadth was measured as well. So to multiply this out, just straight to the point, I have 10.2 times 9.4 times 9.4. And of course the answer boils down to be 95.88. This is 95.88 squared centimeters. That is the area. But I'm interested in knowing what the area and the error limit are. So the error limit is simply the absolute error in the area. And of course I don't really know this. But from the formula we derived so far, that's for error in products. Alright, so for error in products we have the fractional error or the relative error in the area, and this would be the relative, this is the plus or a minus, and this would be the plus or a minus in the relative error in the length plus the relative error in the breadth. Alright, so I don't know this, but I know this term. So this is plus or a minus relative error in A, which I don't know, but the area is 95.88. Of course, it's in squared centimeter. This is a plus or a minus in the length. This will be 0.1 divided by 10.2. That's the fractional error. That's 0.1 divided by 10.2. And I have a plus. Then for the breadth, this is 0.2. That's the absolute error divided by the measured value. That is 9.4. Alright, for the sake of time, I need to wrap it up here. And I'll proceed from here from the subsequent lecture. Thank you.